So this assignment tests basically everything from the first half of the unit. Okay, that starts out with stuff as simple as t equals 1 over f. Okay, v equals 2 pi r over t. Okay, centripetal acceleration is v squared over r. Okay, and then it goes into centripetal force, just the formula for centripetal force. Okay, Fc equals mv squared over r. So there's a bunch of questions on here that they're just going to go like that. Okay, they're really straightforward. They're going to go fast. And then it'll get into some unbanked curves, some banked curves, and some vertical circular motion. Okay, I think I even put an artificial gravity. Did I take it off? I can't remember that. Anyway, it's everything from the first half of this unit. Some of it's going to go really fast, some of it's going to take you a little bit longer, but none of these questions are any more difficult or any different than the ones we've been working on. Okay? So, for question number 1, okay, don't overthink it, it's only out of 3 marks. Okay, they tell you the speed of the blades and they tell you the radius, and they want to know how much time it takes for them to make 1 revolution. Okay, so you just have to, that one's more of a terminology, remembering what the time for 1 revolution is called, than it really is a challenging math problem. Okay, second one, horses race around the circular track in a time of 18 seconds. That's the time for 1 revolution. Okay, with a speed of 17 meters per second, what's the radius of the track? Again, don't overthink it. It's only out of 3 marks. Okay, there's not much there. Number 3 is talking about magnetic tape being spooled from a supply reel to a take-up reel. You guys, this is a generation gap question. Back when I was your age, we had music on these plastic cassette tapes.
Oh, CD tapes.
No, they're not CDs. Cassette tapes. Cassette tapes. Totally different. Compact disc is different. This is a cassette tape. It had brown tape that had magnetic stuff in it. And it would reel from one reel off of the other onto the other. It would just pull it and it would play it. And you press play and you could rewind and fast forward. But you couldn't skip. Yeah. You guys have it so much better. You can put every song I ever had on tape on your phone, and it takes up no space at all. It would have required 4 boxes of cassette tapes, okay, to store that much music back in my day. So you got it so good. You guys got it too good. Anyway, so it's just talking about the reel going like this, pulling on the tape, and it's just asking for the centripetal acceleration, okay, of that tape going onto the reel. It gives you the speed, it gives you the radius. Okay, again, don't overthink it. Right? Number 4, race car travels at a constant speed around a circular track. They give you the radius, but it's in kilometers. Okay, car goes around the track in 360 seconds. Again, time for 1 revolution. What's the centripetal acceleration of the car? Okay. Number 5, how many people have actually played real pinball? Okay, like, I mean, you've probably played like the electronic on your phone version of it, but okay, real pinball actually involved like taking a spring-loaded plunger, pulling it back, and we hit a ball bearing, a big metal ball, okay, and fire it around like an arc. So that's what it's talking about, is this ball going around this arc on a track. Okay, so centripetal force is given, the mass is given, the radius is given. You're just looking for the speed of the ball. Don't overthink it. Okay, like these first 5 questions should literally take you 10 minutes, okay, or less. Number 6, child's whirling a ball on a horizontal string. So it's like what I was doing up front with the tape, just whirling it above their head in a horizontal circle. Okay, they tell you the radius, they tell you the period. Okay, they just want the centripetal force, and then there's an explanation question / calculation question. So for part B, if the speed is doubled, does the centripetal force double? If not, by what factor does the centripetal force increase, and why? You don't necessarily have to calculate anything for part B. You can if you want as proof, but I do want an explanation. I don't require the proof if the explanation is good. Okay, so you can choose on that one. For number 7, bank curve question. Okay, they're asking you what angle it needs to be banked at for a radius and a speed that they give you. Okay, in number 8 is a bank curve question as well. They just give you the radius and the angle of bank and ask for speed. That would be under very icy, means no friction. Okay, friction is negligible. Number 9, we're getting into vertical circles here, so they're talking about apparent weightlessness. They're giving you a speed and asking for the radius. We may have done a question like that today. Question number 10, over the top of a vertical circle, so 10's a vertical circle as well. Okay, 10's probably like one of the tougher ones on the sheet, and it's not terribly difficult. Number 11, roller coaster, so bottom of the loop, okay, vertical circle. Number 12 is also a bottom of the vertical circle, but it's a wrecking ball. Okay, so I don't know if you're swinging in like a wrecking ball, so it's like that. Okay, so yeah, you got the radius there. For number 12, sorry, number 12 is the wrecking ball. Number 13, okay, is an unbanked corner. So it actually shifts back from vertical circles back to an unbanked curve question, but you guys know how to do unbanked curves, so 13 is your unbanked curve. Okay, like I said, don't overthink them. Everything is there that you need. Right? Some of them might be two-step questions, but there's nothing there we haven't done multiple times already. Okay, you got the rest of today's class, that's 25 minutes, plus you'll have all of tomorrow's class to work on this, so don't do it for homework tonight, or you'll have nothing to do tomorrow.